Sometime around 400 BC, right in the middle of the scorching Persian desert, where the ground cracks from the heat and the air literally burns your lungs, something was happening that a modern person would probably consider pure magic. Picture this. It's a brutal 115 degrees out there in the shade, but wealthy Persians are sitting in their open-air tents, sipping ice-cold sherbets mixed with actual crystal-clear ice. They didn't have electrical outlets. They knew absolutely nothing about compressors, toxic freon, or copper coils. And yet, they had ice, all year round, right in the middle of the boiling sand. Now let's fast forward to our reality. Today we buy these so-called smart refrigerators for $2, 3, sometimes even $5,000. They're covered in screens, they connect to Wi-Fi, they can order your groceries, and they send notifications straight to your smartphone. But if the power goes out for even just 5 hours during a summer storm, this shiny $2,000 piece of plastic and metal instantly turns into a useless box full of rotting food. The appliance industry has us completely hooked on the power grid, and they've built planned obsolescence into every single machine. A modern refrigerator is literally engineered to break down just a couple of months after your warranty expires. The compressor seizes up, the motherboard fries from a power surge, and the guy from the repair shop just smiles and tells you it's cheaper to buy a brand new one. But what if I told you there's a building technology that lets you store tons of food and even manufacture ice in 110-degree heat without using a single kilowatt of energy? A technology that works for centuries, requires zero repairs, zero maintenance, and zero refrigerant refills. Ancient Persian engineers created a completely off-grid cooling system that still makes modern engineers scratch their heads. It's called a yakhchal, and the way it's built completely flips the script on everything we know about passive architecture. It shows us exactly how much corporations are ripping us off by selling overly complicated, short-lived solutions instead of things that are simple and built to last forever. To understand why a yakhchal is a stroke of absolute genius, and not just some ancient mud cave, we have to travel to the ancient city of Yazd. This is one of the driest, hottest places on Earth. In the summer, it practically never rains, and the sun burns everything to a crisp. In a climate like that, preserving food isn't about comfort. It's a matter of basic survival. And Persian architects solved this problem by making a deal with nature itself and the fundamental laws of thermodynamics. When you first see a yakhchal from the outside, it looks like a giant clay dome or a massive cone just sitting alone in the desert. These structures could reach up to 50 feet high, with walls at the base over 6 feet thick. But all the magic is hidden inside and underground. The dome is really just the tip of the iceberg. Beneath it lies a massive subterranean chamber, sometimes holding up to 150,000 cubic feet of space. And inside this chamber, the temperature stays right around freezing all year long. How do you actually achieve that when the ground outside is hot enough to fry an egg? The first thing the ancient builders started with was the material for the walls. Ordinary brick or mud wouldn't cut it. It would absorb the heat and let it leak inside. So the Persians invented a revolutionary mortar called saruj. It was a very specific blend of sand, clay, egg whites, lime, goat hair, and wood ash, mixed in precise proportions. They would knead this mixture by hand and let it dry for years. The resulting material had some mind-blowing properties. First, it barely conducted any heat at all, acting as the ultimate natural thermos. Second, it was completely waterproof. And third, it reflected most of the sun's radiation. Walls made of saruj were so incredibly tough that neither torrential rains, sandstorms, nor centuries of neglect could break them down. But just building thick walls isn't enough. Heat will always try to find a way in. And that's where the unique geometry of the dome comes into play. Take a look at its conical shape. Sunlight never hits a cone evenly at a direct angle. At any given moment, half of the dome is either cast in shadow or receiving sunlight at a very sharp angle, which drastically cuts down on heat absorption. On top of that, hot air inside a room naturally rises. That's basic physics. The Persians left a small opening at the very top of the cone. The hot air would gather there and escape completely unhindered, creating a natural upward draft that pulled cooler air up from underground galleries. But the real secret of the yakhchal, the thing that baffled Western researchers for decades, was how the Persians actually made the ice. It's one thing to keep something cold if it's already cold. It's a whole different ballgame to freeze water from scratch in the middle of a desert. For a long time, people assumed they just brought ice down from the distant mountains during the winter. Now, in some areas, they did do that, but in Yaz, they manufactured ice right on the spot, using a phenomenon that modern air conditioning companies would rather keep quiet about. It's called radiative cooling to deep space. Here is how the process actually worked. Right next to the clay dome of the yakhchal, they dug long, shallow channels running from east to west. On the south side of these channels, they built massive, towering walls. During the day, these walls cast a deep, continuous shadow over the water in the channels, preventing the sun from heating it up. But the real magic happened at night. In the desert, nights get incredibly cold because there are no clouds to trap the heat. The clear desert sky acts like a massive open window looking out into the freezing void of deep space, where temperatures are near absolute zero. At night, the heat from the water in those shaded channels would literally radiate out as infrared energy, shooting straight into the cosmic void. The water lost its energy at a massive rate. The physics behind this are so powerful that even if the surrounding air temperature at night was around 40 degrees Fahrenheit, the water itself would drop below freezing and turn to ice. Every single night, they would break up the thin layer of ice that formed in the channel and carry it inside the underground chamber of the yakhchal. There, they would pack the pieces into dense layers, separating them with dry straw for extra insulation, and pour water over it so it would fuse into one massive solid monolith of ice. By the time winter was over, the underground pit was packed with hundreds of tons of ice. Thanks to the massive thermal mass of this giant ice block and the flawless insulation of the sarouj walls, the ice melted so slowly that it lasted all through the scorching summer until the next winter. To make things even better, the yakhchal was often connected to Badgir's ancient wind catchers that captured even the slightest breeze. These towers channeled the wind downward, passing it over underground aqueducts filled with cold water. This ice-cold air didn't just preserve the food in the storage facility, it was funneled into neighboring homes as a primitive form of central AC. It was a completely integrated, zero-emission climate control system for the entire city. Let's do a completely honest consumer and financial audit here. Take your average high-end modern refrigerator. You hand over a couple grand at the store, and from that exact moment, you are locked into a lifetime financial subscription. Every single month, it drains electricity that you have to pay the utility companies for. Inside, you've got fans, sensors, control boards, and most importantly, the compressor. The compressor is the heart of the system, a mechanical part that is constantly rubbing, heating up, and under immense stress. According to data from major repair shops, the average lifespan of a modern compressor is only 5 to 7 years. Replacing a blown compressor, along with the labor and the refrigerant recharge, will cost you easily half the price of a brand new fridge. And that's not even counting the hidden costs. Think about how the shelves and seals are made. Plastic degrades, rubber gaskets dry out, and start letting warm air leak in. The fridge has to run twice as hard, draining even more power. Every few years, you're dealing with minor breakdowns, calling technicians, and throwing out spoiled food. Then there's the environmental toll. Refrigerants, even the newest ones, require hazardous waste disposal, and older freon models are still destroying the ozone layer in landfills, where millions of them get dumped every single year. The industry has created a perfect business model based on replaceability. It is not profitable for them to sell you something that will last for your grandkids. They want you buying a new gadget every few years, using marketing gimmicks like voice control or custom LED lighting to make you feel like you're missing out. It's a massive scam wrapped up in the illusion of technological progress. Now look at the yakhchal. Sure, the upfront cost to build it in ancient times required community effort. But once those walls dried, its operational costs dropped to absolute zero. There isn't a single moving part in it. There's nothing to break, nothing to burn out from a grid power surge. Walls made of mud, ash, and goat hair actually get stronger over time. basically turning into solid stone. The only maintenance a yakhchal ever needed was a fresh layer of mud plaster every few years to protect the dome from rare rainstorms. The cost of that maintenance? A bucket of free dirt under your feet and a couple hours of work. The paradox is that an ancient passive system that costs 0 cents to run is actually more effective at giving a person true independence than the entire weight of Silicon Valley. A yakhchal protected people from inflation, from crises, from the unpredictability of the weather, and from utility monopolies. It was a monument to genuine autonomy. Obviously, nobody is telling you to go out, rent an excavator, and build a 50-foot clay cone in your backyard today. In a modern city, that's just not going to happen. But the underlying logic, the engineering principles built into the yakhchal can and absolutely should be used today if we want to stop bleeding money on utility bills. Today, these exact principles are making a comeback in the form of zir pots, clay and clay refrigerators that use evaporation to keep fruits and vegetables fresh for weeks in places like rural Africa without electricity. Eco-builders around the world are going back to passive root cellars and underground storage rooms, using the thermal mass of the earth and natural ventilation principles taken straight from Persian builders. They are walking away from power-hungry industrial refrigerators in favor of architecture that can think for itself. The construction industry and appliance manufacturers have spent billions of dollars convincing us that comfort is only possible through complication, through wires, grids, plugs, and endless monthly bills. They made us forget that the most powerful forces in the known universe are completely free forces of nature: gravity, thermal buoyancy, and the radiative cooling of a clear sky. The Persians understood this 3,000 years ago. They didn't fight the desert climate. They forced the desert to make ice for them. This ancient knowledge wasn't tossed aside because it stopped working. It was intentionally pushed to the margins of history because a self-sufficient, independent human being is the ultimate nightmare for the corporate consumer model. If you can cool your home and store your food for free using the physics of the earth and the sky, you stop being a profitable customer. You fall right out of the loop of continuous profit extraction. Using the Earth's thermal mass, geometry, and the right materials to control temperature isn't some primitive phase of evolution we outgrew. It is our future. But if using the cold of the earth and sky sounds powerful, imagine what happens when you take that exact same logic of passive natural processes and turn it completely on its head. What if a simple, cheap plastic pipe buried just a few feet down in your garden could completely wipe out your heating bills in the winter and your AC bills in the summer? The physics hiding right under your lawn can deliver results that would make energy monopolies shake with rage. And how to make the Earth's natural thermal engine work for your wallet without a single expensive sensor or moving part is exactly what we're breaking down in our next video on Earth Tubes, which is waiting for you right on your screen.